Hello everyone, welcome to TriRide, the new era of learning. Myself Rafiq. So today we're discussing about introduction to the artificial neural networks, which is the most and a popular concept in the artificial intelligence. Okay, so about this topic, little bit we gained some little bit information about. So in that we are discussing about contents. For we discuss about the introduction, biological neural models, and artificial neural models, and artificial neural networks again, and neural networks, architectures, learning, and back program. Back propagation algorithm and applications. Right. So let us take the task. So, and after all, final advantages and conclusion, right? So, for the first part, we're discussing about now neural networks is the one of the high demanded, right? Which can train a robot and which can create a virtual brain of the human, right? It creates a virtual brain of the human for the robot, right? So, neural networks is an adjective for the neurons, and networks denotes a graph-like structure. Artificial neural networks are also referred to as an neural nets, artificial neural systems, parallel distributed processing system, connectionist systems where works. Okay, so for the computing system to be called by those pretty names, it is necessary for the systems to have the labeled directed gap structure where nodes performs some simple computations like we all know that we see the neurons and Cyberness, where it performs a neuron network structure like which performs some transforms some data from the neurons. Okay, so directed graphs consist of a set of nodes uh, and the set of connections which called as parameters. We all know that called as parameters, and a graph said to be labeled graph if each connection is associated with a label to identify some properties of the connections. And here we see the conclusion. Here we see some little bit. We have it called gates, right? We have the logical gates, right? So in that we said the AND gate graph and the and figure two also AND gate the neural network. Okay, AND gate graph and AND gate network, right? Anyway, see the multipliers where taking the two inputs. Okay, we're taking the two inputs and we call as middle layer. It forms the one output, right? Uh, it the graph cannot be considered a neural network. Since that connections between the nodes are fixed and the appears to play not other role. Okay, it's just which is considered. It only takes the path. Okay, then carrying the input to the nodes that computed the conjunctions, right? It plays only no other roles. It does not consider about the other roles. It plays only the particular path role which is chosen, right? In the same way, gate network, the graph structure which connection the weight modifiable using a learning algorithm qualifies the computing system to be called an artificial neural networks, right? The field of the neural networks was pioneered by the Bernard Vidro Bernard Vidro of the Stanford University in 1950s. So, a biological neural model, like the biological neural model which present in the mostly in human brains, right? We can see the four parts of the critical nervous cells. Some little bit pronunciation will get mistakes. I hope you guys are understand it. We cannot like, translate this into a simple way. So we called as dentaries, which accept the inputs, and soma process the which process the input, and axon we already discussed about it, and axon is turns the processed input into the output, and synapse that electrochemical contacts between the neurons, right? The four parts of the we discussed in the previous neural networks. I show the structure of the axon and the synapses. Okay, once you can get the video and check it. And artificial neural models. Inputs to the those networks are represented by the mathematical symbols. Okay, we are giving the inputs by n number of inputs. Like we take the x of n, and each of those inputs are multiplied by the connection by the weight, which is multiplied by the w of n. Right, we call the parameters. Okay, the connections were multiplied with different parameters. Right, we calculating the sum of w1 by x1 plus up to n number of wn by x1 xn. Right, those products are simply submitted fed through the transfer function of f of x to the generate the result to the output, proper output. So here different here we can see the input to the networks are represented by the mathematical sorry, reading in and uh, terminology. Terminology, we can see the biological terminology, yes, an artificial neural network terminology, neurons, and then synapse, synaptic efficiency, uh, firing efficiency, artificial neural network terminology, nodes, unit, cell, uh, and connections, edges, links, connection strength, weight, bias, and we also consider weight also in that. In artificial neural networks of ANN are programs designed to solve any problem by trying to mimic the structure like and the function of the nervous system. Like mimic is nothing but we are dubbing like clone. Which in instead of that we said as a clone of the structure. If you present the human like the clone robot, create a robot that's like the clone of the human structure, or we take the voice of somebody and we recognize we use the voice assistant to recreate the voice again by other person voice with other person's voice. Like that, we use the mimic of the structure and the function of the whole nervous system. So it is nothing but we say the virtual neural networks of the artificial intelligence we created by the human brains, which is based the concept based on the human brain, right? Neural networks are based on the simulated neurons, which are joined together in a variety of ways of the forms networks, right? It is a multiple zigzag connections where we said the feedback connection and feed forward, right? Neural networks are basically the human brain in the following two ways. In neural networks, accurate knowledge through learning, and in neural network, knowledge is stored with it in the interconnection strength, known as a synaptic weight. And artificial neural networks about the model. So you see here the model description here. We have the connections, inputs, and hidden layers and output layers, which forms a. I already said in the neural networks. Each connection, we take the circle one and circle two. Let us consider as circle A and circle B of these networks. So here we can gain something in from here. The both circle A and circle B were considered the networks, and after that it creates the another circle, right? It creates the another hidden layers. It forms the hidden layer. Each hidden layer read every circle of A and B information. It carries some little bit of information. Each hidden layer recognize and they call the circle and read the whole path. And after that, it forms them. It recognizes, it identifies, it analyzes, and it predicts the proper output layer, right? So, for instance, neural networks includes the connections called weight because the neurons, okay, actual option it combines, right? There, the figure showing the adjacent of the neural networks, right? Here is the both two figures, artificial neural network works model and showing the adjacent neural network, right? And the input node and the hidden layer, right? And the output. So the finally we concluded that the fully connected neural network is the network of the which in the every node is connected to the every other node. Oh, we said that. Okay. So the input layer it must connect with the hidden layer. After that, connect with the output layer. Again, it come back, it rotate to the input node and it regain its update itself like that. So those connections may be either exactly for positive weight, inhabitatory, negative weight, or irrelevant. Okay, almost zero weight. So in layered networks, we have a only in both difference of fully connected networks and layered networks, nothing but it follow fully connected networks follows the straight path. Okay, it follows the straight path to the forward connection. In layered networks, it follows the circular path anywhere. Where the neural network gets triggered, and there we form the layer, right? From the layer zero input to layer one, layer two, layer three of the output layer. And those are the networks in which the nodes are partitioned into the subsets, all the layers which have the no connections from the layer. Okay. So here we said the consider of the acyclic networks and the feed forward. Already discussed about the feed forward networks and the of feedback networks, right? Acyclic network is nothing but wherever the input wherever the input triggers, the output layer must be into the hidden layers, right? This is a subclass of the layered networks in which there was no intra-layer connections. In the other words, we can say the connections maybe existed between the node and the layer, right? And I am any node in the layer of from the input to the output, but the connection is not allowed from the like we take as an input I and the output as a j. From the between the input and output, we can see the similarities of the greater than or equal to or less than, right? It is nothing but allowed. And feed forward, we all know about the feed forward. So this is the subclass of the isolate network in which the connection is allowed to the from a node in a layer in only to the nodes of the layer I plus one. Like it increases the nodes, like every sum of the nodes, it increases by step, right? So, modular neural networks. The modular neural network is nothing but many problems or best solution using the neural networks whose architecture consists the several modules which space interconnections between them. The modules can be organized in the several different ways like hierarchical organization and successive referent, okay, input method. So, from the overall learning of the neural network, the neurons or the animal is an animal's brain or human brain or harder to the wide, right? It usually observes those the animals or specifies the higher order animals and has the growth. Okay, how does this learn occur? So what are the possibilities? We use the mathematical models for the learning, and it is artificial neural networks. Learning refers to the methods and the modifying the weights of the connections between the nodes and the specified networks, right, of the neural network. So the learning ability of the neural networks is determined by the its architecture and by the algorithm method chosen by the training. Okay. So, mostly in machine learning, we have the parts of supervised learning and unsupervised learning, right? Let us consider supervised learning. So, in supervised learning, we have the teacher is available to indicate whether a system is performing correctly or to indicate an amount of errors in system performing. Here, a teacher is a set of a trainer, right? Is the data. Supervised learning is mostly deals with obviously deals with labeled data, right? Where unsupervised data deals with unlabeled data. So the training data of the consistent of the supervised learning of the page input and describe output value. They traditionally represent in the data vectors, and the supervised learning can also refer as a classification and where they have a wide range of classifier, multiplier, and K nearest. Okay, KNN. We all know the most popular algorithm in supervised learning. And when it comes to the unsupervised learning, we discussed it about it. It deals with the unlabeled data, right? So this is the learning by doing. In this approach, no sample output are provided the networks against which it can measure the productivity performing for the performance for the given vectors the input. Once common from the unsupervised learning is clustered. Most we can take the K mean also in that. Also whether we can try the categories data in different clusters, right? We all discussed about the clusters in the previous part. We divide a proper group while doing the clusters. So let now comes to the picture of back propagation of algorithm. And back propagation algorithm is nothing but the back propagation algorithm is it is a used layer for the feed forward. It is the artificial neural network of the feed forward, like a symbol. So Rumelhart and the MC McClellan in 1965 is a user in the layered for feed forward artificial neural networks. For the back propagation is a multi-layered feed forward supervised learning, neural based, network based, and coordinated descent learning rules. Okay. From we provide the algorithm with example of an inputs and outputs we want to the network to the compute and those then the errors. Difference between the actual and the expected results is calculated by the back propagations. The behind the scenes, right? We call it the behind the scenes of the neural networks. And the idea of the backpropagation algorithm is to reduce the errors until the artificial neural networks learns from the training data. And the activation function of the artificial neural networks is an ANNs. An implementation the backpropagation algorithm is a weighted. The sum of the inputs of we call as x of a and the multiple by their respective weights of wj. So this is the some basic formula which can we implement the formation of the neural network as a basic structure, right? We calculate the input values. We have the structure of weight V and the weight W as a basic block of the black propagation neural network. We form the formation. The most common output function is a sigmoidal function. So since the error is the difference between the actual and the desired output, the error depends on the weight, and we need to adjust the weight in the order to minimize the error. We can define the error function for the output of the neuron. So the backpropagation algorithm now calculated how an error depends on the output, input, and the weight. The adjustment of the each weight will be negative of the constant, okay, and multiplied by the dependency. And it's nothing but it's a simple summary, a simple statements of the formal description. we need to calculate how much the error depends on the output, and next how much the output depends on the activation, which is turns the depends on the weight, and so the adjustment of the each of the weight. So if you want to adjust the weight, the let let's call them from the previous layer, we need to first to calculate how the error depends not on the weight, but in the input form of the previous layer, replacing by the W by X as shown in the below equation, right? So let's come to the end of the topic. So in the end of the topic, we gain that neural networks is a uh, high demanded application because we use in robotics, in each and everything. We use in the medical industries, in the air force, in army, in missile detection, in factories, in robotics, in space aeronautics. We use in many industries, from research labs, in chemical waste. So we use everywhere in the neural network because we are learning something new from the neural networks by day by day. So overall, the advantages of the neural network is nothing but it involves a human be-like thinking. They handle the noisy or the messy data. They can work with the large number of the variables of the parameters. They provide the general solution with a good predictive accuracy. System has good probability, like because the proper continuous learning. The deals is the non-linearistic in the world in the which the we live. So overall, nothing but this is the topic about the artificial neural networks. I hope you guys all are understand about it. So thank you.